complete talking about the organic compound. In last session, we talked about carboxylic acids and esters compound, okay? And we know that carboxylic acid means they are organic compound that have functional group known as carboxylic group. It's a symbol COOH. And also we knew the common name of acids in Latin language, which coming from Latin name of the source of the acids that used to prepared, okay? And also we know the name of the acid according to Iophic system. After carboxylic acid, we talked about esters compound, and we know that esters compound widely spread out in nature in animal and plant materials, okay? Also, we know that esters are formed and prepared in lab by the reaction of carboxylic acid with water, which is considered reversible reaction due to the reaction of water with the ester and return back to alcohol and carboxylic acid. And also, okay, revised that the sources of esters, the order of esters, the nature of esters, okay, and how to name the esters compound according to common name and according to Iophic system. Today, we will continue the hydrocarbon derivatives, okay, and we will talk about aldehydes, ketones, amines, and amide, okay? Let's start with aldehydes. Aldehydes, they are organic compound that contain functional group CHO. The name of aldehyde coming from the corresponding alkanes by knowing that the number of carbon, and we replace the letter E in the name of the corresponding alkane by Al. So the name become, in case of methane, it will be in aldehydes compound methanol, ethane, ethanol, propan, propanol, and so on, okay? Also, the name of aldehydes, okay, the common name coming from the corresponding common name of acids, okay? As formic acid, it will form a formaldehyde. Acetic acid, acetaldehyde, and so on, okay? After aldehydes compound, we have ketones. Ketones, they are organic compound that have the functional group CO. The name of ketone also coming from corresponding alkanes by replacing letter E from the name of the alkane by one, okay? Like propan become propanone, butane, butanone, and so on. Also, in hydrocarbon derivatives, we have compounds that contain nitrogen, like amines and amide. Amines compound, they are organic compound that have functional group, amino group. Its chemical formula NH2, okay? And their names coming from the corresponding alkane also by replacing the letter E by amine. Methane change into methanamine. Ethane, ethanamine, okay? Butane, butanamine, and so on. The last group, amide compound. Amide compound, they are organic compound that have functional group CONH2 and their name coming from the corresponding alkane by replacing suffix E or letter E by amide. Example, ethane become ethanamide. Okay, propan, propanamide, butane, butanamide, and so on. Today, we will talk about the important chemical reactions in organic chemistry. The important chemical reactions include 5 types. Type number 1, substitution reactions. 2, addition reactions. 3, esterification reactions. 4, polymerization reactions. 5, dehydration reactions. where the first type is substitution reaction. It's a type of chemical reaction in which element can replace another in its compound due to its activity. While addition reaction means the reaction which include two substances react together to form one substance, okay? Esterification reactions means the reaction between carboxylic acids and the alcohol to form esters, because esters are very important organic compound that used in commercial production and in industry of perfumes, food additive flavors, okay? So esterification reactions are a very important reaction. Polymerization reaction include the reaction between small organic molecules to form a polymer, okay, which is used also in industry to make nylon and Teflon, okay? This is two materials used in industry, okay? The last one, dehydration reactions. Dehydration reactions include the reaction in which the compounds lose one molecule of water, okay? Let's start with the substitution reaction. Substitution reaction in organic compound, okay, defined as a type of chemical reaction in which halogen can replace hydrogen in its compound. What's meant by halogen? Halogen, a group of nonmetal elements, okay? They are the strongest nonmetals, and they include fluorine, chlorine, bromine, iodine, okay? In this case, we react methane. Methane related to alkane organic compound, aliphatic hydrocarbon. Methane react with halogen, where the halogen used in chemical reaction, in this case chlorine, okay? In the presence of ultraviolet rays, okay, the reaction required the presence of ultraviolet rays, or by using or heating up to 400 degrees Celsius, okay? What happened? A series of substitution reaction, because chlorine, nonmetal element, more active than hydrogen, so it can substitute it in its compound. The first chemical equation illustrates that the chlorine can substitute hydrogen, one hydrogen in methane, and form hydrochloric acid, okay, and methyl chloride will be formed, okay? As we know, we note that chlorine can substitute one hydrogen, okay? After that, methyl chloride can react with more chlorine gas to form dichloromethane or methylene chloride, and hydrochloric acid gas will be formed. The dichloromethane can enter the chemical reaction with more chlorine and form trichloromethane, which is known as commercially bichloroform, chloroform product that used in making many materials in industry, okay? Then trichloromethane also can react with the chlorine gas and form tetrachloromethane, okay? And hydrogen chloride or hydrochloric acid gas will be formed. This is types of reaction known as substitution reaction, okay? That require the presence of ultraviolet rays or increasing or heating up the temperature up to 400 degrees Celsius. Okay, thank you. Grade 11.